Why did the global financial system silently abandon the traditional gold standard for a new invisible reserve currency? The answer came in June of 2026, when the Indonesia Investment Authority deployed $4.2 billion, allocating 30% specifically to digital infrastructure assets like day one data centers. This massive capital pivot proved that raw computational power has officially replaced oil as the ultimate sovereign wealth reserve. Welcome to the new macroeconomic reality. For the last 50 years, global power was defined by a simple arrangement, the petrodollar. In the 1970s, the United States struck a deal where all global oil transactions were priced and settled in US dollars. If you wanted energy to heat your home or fuel your factory, you needed dollars. That demand gave the United States an exorbitant privilege, the ability to run massive deficits while the rest of the world absorbed the debt just to keep their lights on. But oil is no longer the bottleneck of human progress. We have entered the era of the compute standard. Instead of barrels of crude, the modern world runs on processors, bandwidth, and gigawatts of electricity. The nations that control the server clusters control the future of artificial intelligence and the future of global economic dominance. It is no longer just about writing software. It is about owning the physical infrastructure required to run that software at a planetary scale. Look at the numbers from 2024. That year, global data center electricity consumption hit roughly 415 terawatt hours, about 1.5% of the world's total electricity use. But the real alarm wasn't the baseline, it was the momentum. This consumption grew at a compounding rate of 12% since 2017. Digital infrastructure expanded 4 times faster than overall global electricity demand. The explosion is clear. Forecasts from the International Energy Agency show that global data center electricity consumption will climb from 415 terawatt hours in 2024 to 945 terawatt hours by 2030. This is not a gradual evolution. It is a violent infrastructure shock. What is driving this? It comes down to a single concept, the hyperscaler. You hear this term constantly in financial circles now. Imagine a traditional data center as a local municipal airport. It has a few runways, handles regional traffic, and meets a specific local need. A hyperscaler is different. It is a massive, automated intercontinental shipping port. It is a facility so large that it does not just store data. It dictates the flow of global commerce. These are the sprawling warehouse-sized server farms owned by giants like Microsoft, Amazon, Alphabet, and Meta. They are engineered to instantly scale computing resources up or down for millions of users at the exact same time, moving exabytes of data the way a global shipping hub moves millions of steel containers. The number of these massive facilities has exploded. The global count of hyperscale data centers nearly doubled, surging from 700 facilities in 2021 to 1,297 active sites by 2025. And yet, even that was not enough. By January of 2025, analysts realized that if the growth in chip supply continued, global AI data center power demand would hit 68 gigawatts by 2027. To put that in perspective, that single number almost doubles the global data center power baseline from 2022. It represents a draw nearly equal to the total power capacity of the entire state of California. The physical bottlenecks of this new digital economy are brutal. We are quite literally running out of energy to feed the machines. The numbers tell the full story. By 2026, the transition from traditional computing to AI workloads completely rewrote the energy map. Experts from Gartner projected that global data center electricity consumption would spike to 565 terawatt hours in 2026, up from 447 terawatt hours just a year prior. This was not driven by people watching more streaming video. It was an increase driven strictly by AI workloads. In fact, the electricity consumption from these specific AI servers was forecast to jump by 84%, scaling from 95 terawatt hours in 2025 to 175 terawatt hours in 2026. This appetite for power is forcing nations to hoard compute clusters exactly like gold reserves. By March of 2026, the digital infrastructure stockpile accelerated globally, with 23.1 gigawatts of data center capacity under construction, split across 831 different sites. And the United States is fighting desperately to maintain its monopoly. The Americas region dominates this global compute expansion, securing 17 gigawatts of that new capacity currently under construction. This dominance is highly localized. Among the top US states by data center count, Virginia leads the nation with 566 active or planned data centers. Map out the global power structures, and the asymmetry is glaring. The United States controls over 4,300 facilities, a massive infrastructural moat. Across the Atlantic, the United Kingdom has roughly 540 facilities, Germany has around 520, and France operates about 390. This geographic concentration means the vast majority of the world's raw computational processing happens within a handful of borders, turning these regions into the heavy industry capitals of the 21st century. But holding this monopoly comes with severe environmental and physical consequences. We measure data center efficiency using a metric called power usage effectiveness, or PUE. Think of PUE like the fuel efficiency rating of a commercial truck. If a truck uses a massive amount of diesel just to keep the engine cool while idling, instead of moving cargo down the highway, it is highly inefficient. A data center operates the same way. It draws power from the grid. Ideally, all that power should go directly to the computer processors, the cargo. But because these processors run incredibly hot, a large portion of the electricity is diverted to massive air conditioning units and liquid cooling pumps just to prevent a meltdown. PUE measures the ratio of total power drawn by the building against the power actually used by the computing equipment. The closer the ratio is to 1, the more efficient the system is. That means less energy is wasted merely keeping the building cold. And keeping these facilities cold is becoming a massive crisis. In June of 2026, Cambridge-led researchers revealed that land surface temperatures around AI data centers rise by an average of 2 degrees Celsius, with some areas experiencing thermal spikes up to 9.1 degrees Celsius. They dubbed this the data heat island effect, a phenomenon that alters the microclimates for millions of nearby residents. To fight this heat, these facilities consume mind-boggling amounts of resources. By 2028, AI data centers in the US alone are projected to drain up to 32 billion gallons of water annually. That is the exact equivalent of the indoor water consumption for roughly 360,000 households, just to prevent catastrophic hardware meltdowns. The energy demands are so vast that AI data centers are projected to consume up to 12% of the total United States electricity grid capacity by 2028. This is why in mid-2026, hyperscalers completely abandoned the public utility grids and started buying dedicated nuclear power directly. Because of these acquisitions, uranium futures maintained a tight, elevated baseline near $85 per pound. Tech companies realized that standard power grids could not handle the load, so they started buying nuclear stations outright. And they are planning for a future where the power requirements are almost incomprehensible. By 2030, the power required for a single, advanced AI training run is projected to hit 8 gigawatts. That is the exact equivalent of the total electrical output of 8 full-sized nuclear reactors, just to train one single localized artificial intelligence model. Because of this physical bottleneck, the global geopolitical map is fracturing into a new Cold War. It is a race to control what experts call the compute dollar system. Imagine the global economy as an exclusive, high-speed toll road. In the past, the toll booths only accepted US dollars in exchange for physical goods like oil or manufactured products. Today, the most valuable cargo traveling on this highway is artificial intelligence, instant translation, automated logistics, and predictive market models. The United States is building the toll booths for this new digital highway. By partnering with other nations and supplying them with the advanced semiconductors required to run these AI models, the US mandates that any AI service exported across borders must be paid for and settled using US dollars, or digital stablecoins backed by US treasuries. It ensures that the currency powering the physical machines remains tied to the American financial system. This strategy is already in motion. In December of 2025, the US expanded its plan to monopolize compute settlement by signing the strategic artificial intelligence partnership with Saudi Arabia. This followed a similar agreement with the UAE in May of 2025, deliberately approving the sale of leading-edge semiconductors to state-run entities to cement this new financial framework. Map the geopolitical distribution of these energy demands, and the strategic rivalries become clear. The United States commands roughly 45% of the global AI energy demand, solidifying its position as the primary architect of the global digital economy. Meanwhile, China has secured about 25% of the global demand, positioning itself as the only legitimate challenger to the American compute monopoly. This concentration of energy consumption proves that the future of global GDP will be generated by the nations capable of feeding the grid. And the Eastern Hemisphere is mobilizing rapidly to close the gap. While the US struggles with its aging electrical grid, China has rapidly built out roughly 360 advanced AI facilities, prioritizing state-backed infrastructure scaling. Right next door, India has scaled its own digital footprint to approximately 300 facilities, leveraging its domestic market and engineering workforce to command a seat at the geopolitical table. These nations understand that relying on Western compute infrastructure is an unacceptable sovereign risk in the 21st century. What does all this macro-level infrastructure actually mean for the stock market, the economy, and your wallet? It means the death of the legacy corporation and the birth of the micro-multinational. Historically, to build a billion-dollar company, you needed thousands of employees, massive real estate footprints, and layers of middle management. But today, because sovereign wealth funds and hyperscalers have spent trillions of dollars building out this global compute infrastructure, anyone can rent supercomputing power by the hour. This access to centralized compute allows tiny, lean companies, teams of perhaps 5 or 10 people, to command the productivity of a Fortune 500 corporation. They do not need a legal department. They run an AI legal model. They do not need a graphic design division. They generate assets instantaneously using rented GPUs. This asymmetry is restructuring the stock market. Legacy corporations are suddenly burdened by their massive human payrolls, struggling to compete with agile micro-multinationals that operate with near-zero overhead. The engine of global wealth has shifted from human labor to physical compute. We are witnessing the greatest wealth transfer in human history. The nations, the funds, and the hyperscalers that secure the gigawatts, the cooling water, and the silicon processors are the new global empires. They are not just hosting data, they are minting the new reserve currency. The compute standard is here, the grid is the new gold.